So today we're looking at proof by induction some more, and also something called proof by contradiction. So I'm given this sequence, and I want to prove that explicitly I can find any term using the rule u sub n equals 2 to the n minus 1 for all n in the positive integers. So we start, again, with show P1. And this is our proposition up here. Our proposition is that u sub n equals 2 to the n minus 1. So we're going to check this out in our proposition. U sub 1 equals 2 to the first minus 1. That's equal to 1. And we were given that u1 was equal to 1, so P1 works. Now we're going to assume that P sub k is true. So we have u sub k equals 2 to the k minus 1. And our goal is to show that P sub k plus 1 is true. And we're going to use our given information here. We know that u to the k plus 1 is equal to 2 times u sub k plus 1. And since we've assumed that P sub k is true, we can substitute right here. And now we can simplify. 2 to the first times 2 to the k is 2 to the k plus 1. And there's what we're looking for. So we can say since P1 is true and P sub k plus 1 is true when P sub k is true, u sub n does equal 2 to the n minus 1 for n existing in the positive real numbers, positive integers, by the principle of mathematical induction. We can also prove something by finding a contradiction. And what we're going to do here is we're going to assume that the opposite of our claim is true. And we're going to try to see a contradiction in what we're doing, implying that the opposite is false, and therefore ours must be true. So I want to prove the sum of any positive real number and its reciprocal is at least 2. So I want to prove 1 over x plus x is at least, meaning greater than or equal to 2, for x existing in the positive reals. So we're going to assume that 1 over x plus x is less than 2. And now we're going to try to come up with a contradiction. So we could write this as 1 plus x squared less than 2x. I'm multiplying by x up here. And then we have x squared plus 2x plus 1 is less than 0. and this factors to x plus 1 squared is less than 0. But anything squared I should change that here. But a real number squared cannot be negative. So 1 over x plus x is greater than or equal to 2 by contradiction. Prove that the solution is an irrational number. This is different than solving. We could solve and get a value here, but that's not proving that that value is irrational. It's not proving it. So we're going to assume that 2 to the x equals 3 has a rational solution. So we could write 2 to the a over b equals 3, where a and b are in the set of integers. That's what it means to have a rational solution. It means we can write x as a fraction. And now we can do some manipulation. 2 to the a equals 3 to the b. I'm raising both sides to the b power here. But 2 to the a is even, and 3 to the b is odd for all a and b that are integers. So x must be irrational by contradiction.